So my dear students, we are going to start a very important bit, that is the motion of an object in a plane with constant acceleration. So here I have drawn this figure, you see, x, y, it is the reference frame and the object is moving along this path, right? Along this path it is moving, and we have selected two positions of the object in this plane. One is P, another is Q. It moves from P to Q in time T, and time is being measured from the position at P. At P, T is equal to 0. At this time, its velocity is u along the tangent. That is called the initial velocity. After time t, its velocity at q, it is tangential, it is v. Position vector of this point P is r0, and position vector of this q is r1. Right? So delta r is r1 minus r0. So this is the situation. So the average acceleration between these two velocities, velocity is changing from u to b, the average acceleration is taken as constant. So average acceleration is simply acceleration that is equal to rate of change of velocity. So final velocity is this after time t, that is v minus initial velocity is u by t. So that is the average acceleration or simply a constant acceleration. Therefore, it can further be written as at is equal to v minus u, or therefore v is equal to u plus at. So this relation we got for any object moving in a plane where after time t velocity is v, and initially when t is 0 its velocity is u. So therefore u, the velocity of the object at t is equal to 0, time t is equal to 0, and v, the velocity of the object after time t. So is it clear? So this relation, because this is the final velocity, it has got component along x-axis. If it is resolved, right, its component in two perpendicular direction, along x-axis as well as along y-axis. If we consider, so accordingly these velocities can be resolved. So this can be written like this also. You see, v can be written as vxi plus vyj, where vx is the component of this velocity along x-axis, vy is the component along y-axis, I and j are the unit vectors along x and y. We can write like this. Similarly, u, initial velocity is uxi plus uyj, we can write. And for acceleration in similar manner, we can write acceleration vector is axi plus ayj. So these things can be written in two components in two directions, right, which are perpendicular to each other. So the same relation can be written this way. So means vxi plus vyj, that is equal to u plus at. U is this, that is uxi plus uyj plus acceleration, this is the acceleration, that is axi plus ayj into t. Same thing, we have written the two rectangular components. So this can further be written as Vxi plus Vyj, that is equal to, all i's we will take together, ux, that will be ux plus axti plus uy plus aytj. I have taken simply i's together and j's together, t is multiplied with this. So we can compare both the sides. So we can write Vx is equal to ux plus axt and Vy is equal to uy plus ayt. So in terms of magnitudes along x-axis and y-axis, this relation can be specified. So it is also very important in two perpendicular directions. It is very much convenient to take linear motion because this velocity can be taken along this direction and perpendicular direction, two linear directions, right, which are perpendicular to each other. So this is the first relation for velocity, acceleration and time. Acceleration, of course, it is constant. Average velocity is equal to v plus u by 2. This is the average velocity. Vector sum of these two velocities divided by 2. This is the average velocity of it. And the displacement is equal to delta r is equal to r1 minus r0. So average velocity is this, displacement is this, and this velocity changes during the time t. So displacement is equal to average velocity into time we can take. Therefore, r1 minus r0, this is the displacement, that is equal to average velocity. Average velocity is along the displacement. So velocity is always along the displacement, so that will be average velocity into time taken during the motion, that is v plus u, right, by 2 into t. This we got. And the velocity, what is velocity? We will write r1 minus r0, that is equal to u plus at. We have already got first relation, u plus at plus u divided by 2 into t. This relation is there. So this can further be written as 2u plus at by 2 into t. That is equal to 2ut plus at square divided by 2, and this means this is equal to ut plus half at square, that is r1 minus r0. So two position vectors are there. This is displacement and displacement is equal to this. Therefore r, of course it's r1. R1 means position vector of the object at time t. Means from the beginning it took time t. So final position, there is a position vector, that is r1, that is equal to r0 plus ut plus half at square. R0 is, it is the position vector of the object at time t is equal to 0. At t is equal to 0. If the motion starts from origin, means at t is equal to 0, the position is at origin. In that case, r0 will be 0 right? If motion starts from origin, that is at t is equal to 0, r naught will be equal to 0. Therefore, this equation 1 can be written as r1 is equal to ut plus half at square. This is one relation, this is the relation. So these two are very important relation that will be applied at various situations when we solve the numerical problems. So these two situations should be clearly understood. When r0 is the position vector object, when it starts from origin, it becomes 0. So this can be written in two perpendicular directions in Cartesian form also, right? When r1, this is resolved in two directions. So suppose we can write that also. r1 vector is, suppose its coordinate is x1, y1. Its coordinate is x, y. So r1 can be written as x1i plus y1j. This we can write. r0, this can be written as xi plus yj, because coordinate is this. This is x, this is y. From here to here, it is x1, it is y1. So these two relations are there. And for u and a, we know. So u is equal to uxi plus uyj, a vector, that is axi plus ayj. So these are the situations. So if we convert this in terms of x1 and y1 and all, so this can be written as in two perpendicular directions, along x-axis and along y-axis. So along x-axis, the displacement will be like this. x1 is equal to x naught, that is x is equal to x plus uxt plus half axt square, and y1 is equal to y plus uyt plus half ayt square. These two relations will be getting in two perpendicular directions, where x1 and x is the initial displacement, x1 is the displacement after time t. So change in displacement, right? Change in displacement, we will be x1 minus x. So that can also be written. See, here these things I have written. This is for equation 1. So this relation we will get. For equation 2, when the object starts moving from origin, in that case, this is the relation. So directly we can write in place of x and y, these things won't be there. Therefore, x1 is equal to uxt plus half axt square, and y1 is equal to uyt plus half ayt square. This will be the relation, and these two pertaining to velocity and acceleration, two equations we derived. So these equations will be used very frequently along with these equations to solve the numerical problems. So we will take some numerical problems also based on these equations, then concept will be more clear. A particle starts from origin at t is equal to 0 with a velocity of 10 j meters per second and moves in xy plane with constant acceleration. This acceleration is constant. It's very important. Then we can use the equations of motion. Solution. So what are the equations of motion? Here, at what time x coordinate of particle is 16 meter, means we are concerned with the displacement. The displacement is RT minus R0, right? When t is equal to 0. This is the displacement. Displacement vector is equal to ut plus half at square. This is the equation of motion when the acceleration is constant. So whatever is given, we will simply put in this equation and we will get what are we getting. So this is the position vector at time t. This is the position vector when t was 0. When t was 0, it started from origin, means r0 is 0. Therefore RT, I will write simply R is equal to ut plus half at square, as R0 is equal to 0, right? Starting from origin. So R. Therefore, displacement R is equal to U. Initial velocity is 10j. So 10.0 t and this is j plus half. A is 8.0 i plus 2.0 j, right, into t square. All i's and all j's will be kept together. So 10.0 tj plus, if you multiply by half, you will get 4t square I plus t square j, or 4t square I plus 10t plus t square j, that is the vector r, the displacement. This r can be written as, therefore in Cartesian form, if x and y are the displacements along x-axis and y-axis, so in terms of I and j, this can be written as xi plus yj. This we have already done, right? Any position vector can be represented in the form of xi plus yj. That is equal to 4t square I plus 10t plus t square j. Now we will compare coefficient of I and coefficient of I over here. Therefore, x is equal to displacement along x-axis. X is equal to 4t square. That is 4t square, and y is equal to, then what is y? It is displacement along y-axis. That is equal to 10t plus t square. That is 10t plus t square. So this displacement along x-axis, displacement along y-axis, both we have got in terms of the time taken. But displacement along x-axis is given. That is 16 meter, right? So it is equation number 1. This is equation number 2. From the given condition, 16 is equal to 4t square. Therefore, t square is equal to 16.4. That is equal to 4. Therefore, t is equal to under 4. That is 2 seconds. Means after 2 seconds, the x component will be 16 meter. Corresponding to what is the y component? So in place of t, you will put 2 and we will get y component. Therefore, y is equal to what? 10 into 2 plus 2 square, that is 20 plus 4, that is equal to 24. This y is equal to 24 meter. So this is y component of the displacement, and time taken is 2 seconds. Second part, what is the speed of the particle at that time? Speed we have to find out. That is in the vector form, v is equal to u plus at, right? So initial velocity is known, constant acceleration is known, therefore v is equal to, u is 10.0 j, 10.0 j, right? Plus a is 8.0 I plus 2.0 j into t. That is equal to 10.0 j plus 8.0 ti plus 2.0 tj. So we can write 8.0 ti plus 10.0 j plus 2.0 tj. This is equal to v bar, and v bar, we have to find the speed. So velocity just we'll find, then we'll find the magnitude, that will be the speed. So in 2 seconds, what will be the velocity? Therefore v is equal to 8.0 into t is 2 seconds I plus 10 plus 2.0 into 2j. So what is this? That is 16i plus 14j. 16i plus 14j, that is v vector. Then what is the magnitude of this? Therefore v is equal to mod of v, that is equal to under root 16 square plus 14 square, will 21.26 meters per second. This is the velocity after 2 seconds.